Welcome back. Today we are going to take a look at our second set of population notes. Our two essential questions are, why is population increasing at different rates around the world? And why might the world face an overpopulation problem? A key graphic that geographers use when they study population is the demographic transition model. The demographic transition model shows how population changes over time. It incorporates crude birth rates, crude death rates, and natural increase rates. Here is what a full demographic transition model looks like. If you notice, it is broken down into 4 different stages. Countries throughout the world are categorized into these different stages of the DTM, or of the demographic transition model. A country's stage is based on their crude birth rate, crude death rate, and their natural increase rate. So what are the stages of DTM, or demographic transition? The first stage is a period of low growth. This was Earth's early population, where society was based on hunter and gatherers. People traveled all over and followed their food sources. The agricultural revolution leads to a population growth in larger settlements. Stage 1 of the demographic transition model has a high crude birth rate and a high crude death rate. They also have a near zero natural increase rate. There are currently no countries in Stage 1. Stage 1 of the demographic transition model does not exist on Earth at this time. Here we have Stage 1. Okay. You can see both the crude birth rates and the crude death rates are very high, which means that there is a near zero natural increase rate. Population is not growing, it is simply maintaining. Again, Stage 1 does not exist anymore. Stage 2 is the second stage of the demographic transition model. In the year 1750, the world's population began to increase exponentially, or very quick. That's because there was a drop in the crude death rates as a result of progress from the Industrial Revolution. People began to figure out ways to not kill themselves when they were working in the factories. This also led to higher productivity, wealth, and technology. Europe and the United States entered Stage 2 of the demographic transition around the year 1800. The remainder of the world entered Stage 2 of the demographic transition model around the year 1950, and that was the result of the medical revolution, when Europe and the United States brought medicines to the rest of the world to help starve off infection and disease and reduce the crude death rate. Question number 1. This model incorporates birth, death, and natural increase rate. What do we call this model? Hint, it's the model that we're talking about today during our notes. It's the demographic transition model. Again, here's what the demographic transition model looks like. So far, we have talked about Stage 1, the stage in which you have high birth and death rates and a near zero natural increase rate. Reminder, Stage 1 of the demographic transition model is no longer found on the Earth. There are 0 countries in Stage 1. Stage 2 of the demographic transition model still has high birth rates, but people figured out less ways to die. So your crude death rate is going to decrease. Therefore, your population is going to grow very quickly. Your natural increase rate extends almost all the way up. It's a period of high growth. The United States and Europe entered Stage 2 of the demographic transition model with the Industrial Revolution. The rest of the world entered Stage 2 of the demographic transition model with the medical revolution. This graph shows the rapid population increase that the world saw after the year 1950. Okay? Here you can see that Earth's population remained fairly small, right? Below 1 billion people for thousands of years. And then all of a sudden in the year 1800, humans got smart about not killing each other. and your population begins to increase dramatically. So from the year 1900 to 1950, the population nearly doubles. Then from the year 1950 to the year 2000, the population triples. Okay? This population growth has only continued to grow. Question number 2. Stage 2 of the demographic transition model has a high growth rate due to a drop in crude death rate in Europe. What major event led to this change? It was the Industrial Revolution. Europe and the United States entered stage 2 of the demographic transition model around the year 1750. Stage 3 of the demographic transition model is marked by moderate population growth. Stage 3 has a drop in crude birth rates. Crude death rates are also continuing to decline, but at a more gradual pace than compared to stage 2. Therefore, your natural increase rate continues to decline gradually. Population growth still continues, however, it's not as fast or as rapid as it was in stage 2. The United States and Europe entered stage 3 of the demographic transition model in the early 1900s. This is when American and European families started to have fewer children. Instead of maybe having 7 or 8 kids, they chose to have 4 or 5 kids. Most Asian and Latin American countries entered stage 3 of the demographic transition model within the last 30 years. And many African countries are still in stage 2 of the demographic transition model. They have not been able to make the jump to stage 3. Again, here's what stage 3 of the demographic transition model looks like. Your birth rates begin to decline, so people start to have fewer children, and your death rates are continuing to decline as well. Your natural increase rate begins to decrease. However, your population is still growing because there are more babies being born than there are people dying. Question number 3. Which of the following was responsible for a drop in death rates in many developing countries after the year 1950? That was the medical revolution. Europeans and Americans began to bring vaccines and other medical devices to developing countries to help decrease the crude death rate and increase life expectancy. The last stage of the demographic transition model is stage 4. Stage 4 is a period of low population growth. In stage 4, your crude birth rate and your crude death rate are near equal. Your natural increase rate is near 0, or zero population growth. Zero population growth results from a total fertility rate of 2.1. This means that it results from a replacement rate. Basically, a man and a woman decide to have 2 children. Those 2 children essentially replace the man and the woman as they get older. The United States and parts of Europe are currently in stage 4 of the demographic transition models. Families are choosing to have maybe 1 or 2 children. Again, here's what stage 4 looks like. Your crude birth rates and your crude death rates are nearly even. Therefore, your natural increase rate is near 0. Your population is not growing and it's not shrinking. Instead, it's simply maintaining. Question number 4. Stages 1 and 4 of the demographic transition model are similar in that they both have low growth rates. Remember, stage 1 has high crude birth and crude death rates, and stage 4 has low crude birth and crude death rates. Both result in near 0 natural increase rates and have low population growth. Some geographers argue that there is a 5th stage of the demographic transition model, and this stage would be a period of negative growth, or where your population is shrinking. So some demographers argue that this fifth stage is emerging. In this fifth stage, your crude death rate exceeds your crude birth rate. Most countries in Eastern Europe are actually in stage 5, where they are seeing a negative population growth. This is because people are either choosing not to have children or they're living in a one-child family. Can you think of a country that was successfully able to reduce or stop their population growth by implementing a one-child law? If you said China, you are correct. For many years in Chinese society, families were only able to have one child. The purpose of that was to reduce population growth. The Chinese were so successful at halting their rapid population that the one-child policy has recently been repealed, and families in China are now allowed to have 2 children, with the hopes that China's population is able to maintain its current speed. Another statistic or graph that geographers look at is something called population pyramids. Population pyramids show 2 major statistics. They show dependency ratios and sex ratios. The dependency ratios shows the number of dependents, or old people and young people, in a population compared to people in the working age. The sex ratio, on the other hand, shows the number of males per 100 females. Currently in Europe, the sex ratio is 93 males to 100 females, so there are more women in Europe than there are males. In Africa, the sex ratio is 103 males to 100 females, so there are currently more males in Europe than there are females, or males in Africa than there are females. So how can population pyramids and demographic transition models vary by country? This population pyramid and demographic transition model shows Cape Verde in Africa. From this population pyramid, you can tell that Cape Verde has a very young population, and the majority of their people are under the age of 30. And they have very few people that live to be 70 or 80 or 90. And if they are living to be 70 or 80 or 90, oftentimes the females are living longer than the males. On the demographic transition model, you can see that Cape Verde is still in stage 2 of the demographic transition model, meaning they are having rapid population growth. They have a very large crude birth rate. We can see that in our population pyramid. They're having lots of babies. The largest section, or the largest age group in the population pyramid, is the 0 to 5. The crude death rate is decreasing, so people are starting to live to an older age, and your population growth is going to be dramatic. These are the population pyramids in the demographic transition models for Chile. In Chile, you can see that population is still growing, but at a more dramatic pace. The crude birth rate is beginning to decrease, as we can see in the demographic transition model. You can also tell that the crude birth rate is decreasing on your population pyramid because the bars are starting to get lower or smaller. It's starting to represent an upside-down triangle where it gets narrow at the bottom. The majority of people in Chile are going to be your working class or your working age, so roughly aged 15 to 50. Your crude death rate is decreasing as well. Therefore, your population growth is still increasing, but at a moderate pace. Chile would be in the stage 3 of the demographic transition model. This page shows what Denmark in Europe is like for population pyramid and demographic transition model. As you can see, Denmark is in stage 4 of the demographic transition model. Its population pyramid shows stage 4 because it's pretty even when you look up and down the pyramid. There's not a huge gap on either side. You have about the same number of old people as you do young people. Therefore, your natural increase rate is going to be near 0. Your population is going to remain even. Okay, Who is Thomas Malthus? Malthus was an English economist who lived between the years 1766 and 1834. And Malthus is famous for theorizing that our population will eventually outgrow our supplies. What he's saying is that our population is growing way too fast. And if our population continues to grow this rapidly, there's going to be conflict over resources. Poor countries can't feed themselves, and people are going to starve. People that disagreed with Malthus says that our population can continue to grow rapidly because our supply of resources today can increase. And it's not a supply issue, it's an issue versus distribution. People that believe that Malthus is correct argue that humans today need to figure out a way to decrease our population growth or slow it down. They are concerned that we are going to run out of natural resources. People that disagree with Malthus say that running out of resources is not the concern. Advances in technology and renewable resources are able to help prevent that from happening. And it's not an issue of supply, but an issue of distribution. This map shows the predicted population growth and the predicted resources growth. So here's where Malthus got his argument. He was saying that as our population dramatically increases, our resources will not be able to keep up. And this gap will create war and conflict among humans on Earth. This graph shows that people that are critics of Malthus say that we have made enough technological advances to where resources and population will not be an issue. So as our population continued to grow, we are able to produce more rice and more wheat. So our food resources have actually been able to increase with technological advancements. Question number 5. Thomas Malthus concluded that our population will outgrow our available supplies. This was his theory that many people believe is still true today. So, if we believe that our population is growing too rapidly, how do we go about slowing down that population growth? Well, first and foremost, we need to decrease the crude birth rate. The only way to slow population growth is to reduce the number of babies that are being born each year. Overall, the world crude birth rate has declined over the last 20 years. And that's because crude birth rate can be influenced in 2 ways. It can be influenced through social and economic development, and also access to contraception and family planning through the education of women in the act of marriage. Basically, how it works is that the more education or the more access a woman has to economic or social opportunities, the less children she is likely to have. For example, if a woman chose to end her education in high school, she would look to start a family when she was at a younger age. Therefore, she has more years in her childbearing period. Therefore, she can have more children. If a woman chooses to continue her education past high school and attend a post-secondary education, she would be looking to start having children in her mid to late 20s. Therefore, her childbearing range has been reduced and the number of children she could have is decreased. If a woman chooses to continue her education at an even higher level, past a basic post-secondary degree, her ability or her need or want to start a family or have children would be pushed out even further, therefore further reducing her childbearing range, also reducing the number of children that she could have. Another important way to reduce crude birth rate is the access to contraception and family planning. That's where women get to choose if and when they want to have children. And contraception and family planning are just fancy words of saying birth control. This map shows the women using family planning as a certain percentage. You can see in the United States, roughly 50 to 74% of the women in the United States use family planning or use birth control, meaning they get to decide if and when they have children. If you notice, a large part of Africa has a very low percentage of women using family planning or women that have access to birth control. Because of that, the crude birth rates in Africa are going to be higher. Women are likely to have more children. You notice China's in the highest category for women using family planning. That's because China had the one-child policy for many years, which has only recently been repealed, and the two-child policy has now been instituted instead. Areas like Canada and parts of Europe have a higher percentage of women using family planning or access to birth control due to universal health care. It removes the barriers that women have to obtain birth control and make those choices. Again, the easiest way to curb population growth or reduce population growth is to reduce the crude birth rate. Okay, so now we are at the end of the notes. What you are going to do is you are going to write a 6 to 8 sentence summary to answer these two questions. Okay, I would like 3 to 4 sentences per question. The first one, why is population increasing at different rates around the world? And the second one, why might the world face an overpopulation problem? When you are finished with your notes, upload them to Schoology.